Okay, now we're gonna look at how computers perform calculations on different numbers. As you can see on the screen, we have four different types of arithmetic operators that we use to calculate numbers in math. They work the same way in math, but I just want you to look at their symbols here. And here we have a question. It says write a program that will calculate the product of numbers from 1 to 5. So just pause the video and get to work. So what we have to do is we have to type in cout, and then we have to display the appropriate message, which is the product of numbers from 1 to 5 is, and then close that with a double quotation mark, and then multiply 1 times 2 times 3 times 4 times 5. Well, your solution might be slightly or totally different from this one, but if you did it the same way and got the same results, congratulations. It's pretty simple. So now let's move on to the next part. Right now you might be thinking that why am I learning this? This is stuff I know from grade R. Well, here's a demonstration of why I'm showing you this. Look at the following example. 1 minus 2 plus 3 times 4 divided by 5. So if you type the exact same thing in your calculator, let's say 1 minus 2 plus 3 um, times 4 and close bracket divided by 5, and you will get negative 1.8. Now let's run this and see what we get. We get negative 1. Wow. You were thinking computers were smart. No, 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 they are not. Actually, they are. Well, let me show you something. If you did maths in high school, you might remember the word BODMAS, brackets of division, multiplication, addition, and subtraction. Basically, this is exactly the same rule that is used in programming, and it's the same rules that computers use. As you can see here, the computer will start by the numbers in the brackets, which is 2 plus 3 times 4, which will give us 12, which it's gonna add that 12 to 2, and after that divide that by 5 and then minus 1, and then it's gonna divide 14 divided by 5, which will give you 2. But wait, 14 divided by 5 is not equals to 2. What's going on here? Well, let's take a look at that and see what's going on. Okay, let's check what's happening behind the scenes. So I'm just gonna remove this, remove that, and say 14 divided by 5 and run this. You see, we get 2. It's not joking, it's really 2. Okay, let me explain what's going on here. It's because this is an integer. So remember, integers cannot be decimals. Check what happens when you change the 14 into decimal. It becomes 2,8, which is the actual answer. So remember, decimals cannot be in the integer class, you see. So actually, if you declare a number as an integer, the program will throw away the number after the comma, and it only take the number before the comma, which is 2. As you can see, it threw away 8. Instead of taking 2,8, it threw away the 8, and well, that's very confusing. Don't worry, you get the hang of it as time goes on, and the rest is just history. 1 minus 2 is negative 1. That's obvious. Okay, now let's think, how can I solve this problem? How can I get the computer to give me the actual answer instead of giving me an integer number? It's about what the problem is. The problem is it's giving us a what? An integer instead of giving us a decimal. So we have to change the line into a decimal by making 5 a decimal. As you can see, we got the actual answer. So it's that simple. That's computer arithmetic. That's how they work. Okay, I hope that's clear. So yeah, let's move on. Here is an exciting activity. I want you to guess what the output of the following line is. 6 times 7 divided by 8 times 9. Pause the video and guess. It's 45. Well, that's not the actual answer. Okay, what is going on here? Actually, if you use the same rule, the BODMAS rule, you're gonna get why it's giving you 45 instead of giving you the actual answer. If you don't have a calculator, just watch this part. We say 6 times 7 divided by 8 times 9. The actual answer is 47.25. Well, the same goes for this arithmetic. 6 times 7 will give you 42. 42 divided by 8 will actually give you 5.25. And this is the part where the 2.5 is thrown away and the the other part, the 5 is left. That's because we didn't make this a what? A decimal. So it's actually about how you want your answer to be. If we can change this by making one of these numbers a decimal, it could be 6, it could be 7, it could be 8, it could be 9. In my case, I'm just gonna make 6 a decimal and I'm gonna make it 0 because I don't want to change the original answer. And this is the part where my problem will be solved. That's it for this lesson. Thanks for joining me. See you in the next lesson.